Okay, so we're going to continue on with ballistics notes part 2. Like I said yesterday, this will probably be like the biggest part of our chunk of notes here. So it's going to go through just all the ways we can kind of test different things at a crime scene to match a firearm, match a bullet from our suspect to our crime scene. So first off is just matching the bullet and casing mark. So a bullet or casing in a crime scene can be linked back to the weapon that was used to fire it based on several unique markings. So it's not just the patterns around it. There's a couple different places you can look for a unique marking. So first part is rifling. So these lands and grooves, the pattern inside the barrel is called rifling. And the marks that it leaves on the bullet, you can see these little striations here. Those grooves cut into the spiral down the barrel of the firearm to help increase its range, its accuracy. Like that's why they're there. But they also, even though two guns may be from the same model, the rifling inside the barrels will differ at least a little bit. So basically, it is like a unique fingerprint to that gun. It has to exactly match, like if they're looking under a microscope, it has to exactly match the bullet from the crime scene, the bullet taken in like practice rounds to see if this is the correct gun. But if it does, like that's the gun. So they do have unique markings. As a gun is fired, the barrel marks each bullet with a pattern unique to that gun. Therefore, bullets can be matched to the exact gun they were fired from, like I just said. Bullets become scarred by rifling as they travel down the barrel of the gun. So it leaves those little markings. That's enough. It's extremely difficult to convict someone of murder without the possession of the murder weapon. It just is. So if you can't find the weapon and match it to the wounds, match it to the suspect in some way, hard to get a conviction. So in the case of shooting, matching a bullet with a gun is essential. So if you can't find the bullet, if you can't find the weapon, makes it much harder to really get a conviction. Matching procedure, you're going to fire bullets from a suspected weapon. From the video you should have saw in the opener this morning, they usually fire those into water so that the bullets don't get damaged. We just want to see the rifling pattern. We don't want to like it actually hit something and like get all smushed and things because then we'd have a hard time looking at it. With the aid of a comparison microscope. So they look at it under these microscopes that are really cool because you can put the suspect bullet here, the bullet from the crime scene here. You can see them right next to each other, literally right next to each other, and see if their patterns match. There's also something you can look for called a breech mark. A breech block prevents a cartridge from shooting backwards towards the user. So basically it makes the bullet not go backwards in the gun and shoot the person that's trying to shoot it. That'd be bad. So it has this breech block and that leaves a breech mark. So unique marks are produced on the casing as it moves backward and hits the breech block. So this bullet might be sliding backward, hits that breech block, and it has these identical little scars on the back of the bullet from hitting the breech block. And that should be pretty unique as well. Unique marking on the bullet. There we go. There's also could be a firing pin impression. So the impressions are made on the bottom of the, move me. There we go. Impressions are made on the bottom of the cartridge by the firing pin as it strikes to fire. So depending on the firearm and the type of cartridge used, these marks can appear on the rim or on the center of the used cartridge. So you can also be finding these markings in the center to the little outer rim of it being left by the fire pin, just hitting it as it's going to strike to fire the bullet. So those should be fairly unique and all in the same spot in the bullet of that gun as well. Semi-automatic and automatic weapons also have extractor marks and ejector marks, which are tiny scratches formed from the insertion and removal of the firing chamber. So just loading the bullet can cause certain types of scratches or ejector marks from like it being fired and then popping out. So those scratches should also be unique to the way that gun works. There's really lots of little things you can look for to say it's a match. And the more you can say matches, obviously the better for your case. All right, the next thing, so we're matching the bullet from gun, is we could also match gunshot residue. So if the person has fired a gun, it's going to leave the explosion of gunpowder in the firearm leaves a residue after being fired. That's just what happens with a little mini explosion. So every time you see GSR, it means gunshot residue. So the gunshot residue is trace evidence made of smoke and unused powder particles that can land on the hand, arm, face, hair, clothing of the shooter, the victim. If they're close to their victim, then the victim's going to get that powder on them as well. Even if washed, chemical tests can usually still detect this residue. The amount of gunshot residue decreases as the distance between the firearm and the shooter increase. So basically, you can kind of tell how far away the victim was from the shooter based on if the victim has any gunshot residue on them. If they don't have any, then the shooter was quite a bit further back. Eyewitness accounts are not always accurate, so it is important for forensic detectives to examine evidence to either confirm or dispute witness accounts. So if they were saying that, oh no, he was like right in front of him, got right in his face and shot him, and then you find no gunshot residue, then then they fibbed. They weren't that close. So you can prove it or disprove what an eyewitness says. This is just a person in court testifying. So first step is to figure out if the bullet would let's just say wound. If the bullet wound is from an entrance or an exit, because that would help me determine, like, if the witness says, oh, he shot him right in the front, or he shot him in the back, he wasn't even looking, whatever they're saying, you can try to disprove it based on entry and exit wounds. So entrance wounds tend to be smaller because the skin stretches as the bullet enters. So you hit the entry wound, say they hit a guy right here, it's going to be about the size of the bullet, but as it's going through your body, it's going to expand because it's pushing things out of the way. It's pushing your muscles. It's pushing everything. And all that grows, and it's going to make a bigger exit wound. Clothing fibers are probably going to be found in the entrance unless they didn't have clothing in that spot. But if they're wearing like a t-shirt and they're shot right here, well, when it pushes in, you're going to have clothes right here at the entrance. So it's going to push those clothes into your body. Gunshot residue may also be found on the entrance wound. So you're not going to find gunshot residue on the exit. You're going to find it on the front. So wherever you find the gunshot residue is obviously the entrance place, if they were close enough to have the gunshot residue. If the bullet is from a close contact muzzle, meaning the bullet was touching their skin, okay, so if the bullet is touching their skin, then they're going to leave burn marks. There's going to be burn marks caused by the gun's hot gases as they release. So again, it's like a mini explosion inside the gun. That's what pushes the bullet out. That mini explosion is going to send out hot gases as well that would burn their skin if it was touching. So you're going to see that abrasion ring, a very clear muzzle imprint, are seen in the contact range gunshot. So if they are very close, you're going to see that marking around it. Trigger warning, bloody images, don't look, just listen if you're going to be bothered by that. Since the barrel contacts the skin, the gases are released by the fired round, go into the I can never say this word, subcutaneous? It sounds wrong, tissue, and cause the star-shaped laceration. Note also the gray-black discoloration from the soot, as well as faint abrasion rings. So you can also see the gunshot residue around it, the ring, the leftover bit of smoke surrounding it, as well as the burn markings. Now, exit wounds tend to be larger because the bullet carries tissue and bone that it's picking up as it's going through the person's body, pushing it out of the way, and it's making a bigger exit. It's also slowing down in velocity. Bullets usually do not travel smoothly through a victim, and in many cases will ricochet off bones before exiting, or may not exit at all if it bounces around enough in there. Fast-moving, high-caliber bullets tend to pass through a victim. Obviously, it's a much more powerful gun. It's more likely to just go straight through. It's going to have that more power, more velocity. Small calibers or smaller bullets, lower velocities, they're not going as fast, more likely to ricochet off things and get lodged in the body. Here's a slit-like exit wound. Note that there is no powder or soot visible, so that would mean that they were not right next to them. This is also the exit, so it's like tearing out. So you wouldn't imagine there to be any kind of soot or markings because it's exiting. There may be no exit wound at all if the bullet's energy is absorbed by tissue. So like I said, it could still be in their body depending on type of weapon. Now, how do we collect this evidence? So every time we got to talk about how do we collect our evidence? How do you get sent it off? That's actually what a forensic scientist would do, is they'd care a lot about how it's packaged, how it's sent to the lab, and then what we do with it after. So never submit a loaded gun to a laboratory. That kind of sounds obvious, but like you're like, but there's bullets in it. Like you have to save it. Like, yes, you do. You still have to save the bullets that are in it and keep track of everything, but you should not be submitting a loaded gun, letting it just slide around on its way to the lab. Never pick up a weapon by placing a pencil or other object in the end of the barrel. I don't know why someone would do that. That sounds silly. Putting a pencil in there to pick it up, but I know why. It's because you don't want your fingerprints on it. So you're trying to preserve the fingerprints of the person holding the gun previously. You don't want to add your fingerprints to it. You don't want to rub it off, but don't put anything down the barrel of the gun. Don't do that. Record, serial number, make, model, and caliber of the weapon should all be written down. Place weapons in well-packed, strong cardboard or wooden boxes to prevent shifting of the guns in transit. We're going to have to fire the gun usually to do practice rounds to see if the bullets match for the crime scene. So you need to take a lot of precautions to make sure the gun is still well and intact by the time you get there. If blood or any other materials present in the gun, it should be in paper packaging because it's blood. That's the rule for blood. It's going to mold otherwise. So it has to be in paper packaging to prevent loss of that blood sample as well. Remember, the gun will likely be examined for latent fingerprints, so try your best to not touch it in places that the fingerprints would be held the most and touch it as little as possible. So kind of holding it there like they're probably not going to have a fingerprint in that spot. Now, bullets and cartridge cases, wrap recovered bullets and casings in paper and seal in separate labeled pill boxes or envelopes. Bullets recovered from a body should be air dried and wrapped in paper. Washing may destroy trace evidence. So same thing. If it has blood on it, it should be air dried and paper packaged. That's been true for blood for 2 units now. Always attempt to recover unused ammunition for comparison purposes. So anything that is unused or used, all of it should be collected. Now, how do I collect gunshot residue? So gunshot residue is extremely fragile evidence. It's just smoke from the blowback of a gun and should be collected as soon as possible, preferably within 3 hours of the discharge of that firearm. That's what you would want. So hopefully like you get to the scene, someone's been shot, you have some people running around, you're thinking there might be your suspects. So you're arresting them all at the crime scene. You're going to put bags on their hands like this until you can get them tested, until you can do the swab test for it to see which one of them fired the gun. Hand protection bags are used as well as in suicide cases. I forgot that. So like, let's say you get to a suicide case and you're trying to prove that it's a suicide, or you're trying to see that it is in fact a suicide. So you have your victim, as they're being taken to their autopsy, their hands would also be in bags to see that they had in fact fired a weapon. If they hadn't, then it's not suicide. Submit clothing or other material showing evidence of gunpowder residue or shot holes to the laboratory. So all things that could possibly have that gunshot residue on them would be sent off. Clothing should be carefully wrapped in clean paper and folded as little as possible. Basically, you want them as flat as you can so things aren't being disturbed or moved around. So like if you had the evidence on the front and then you folded it inward, well, now it's on the bottom. So like you want to fold as little as possible, change it as little as possible. And they all have to be packaged separately. Same thing if I package my shirt with the pants. Well, now if I find gunshot residue, was it from the shirt or was the gunshot residue from the pants? But now I put them in the same package and now I'm finding them on both pieces. And I'm like, well, was it on both pieces of the clothing? Or did I just did I package them together and now they both have the same residue on them? How to detect gunshot residue. So the first step is visually, microscopically examine the evidence. You can see it sometimes, like it's powder smoke residue. The presence of any gunshot residues found around the bullet hole, as well as the shape and appearance of the hole, will be documented if you can just see it. The next step involves chemically processing the exhibit for gunshot residues. So there's chemical tests. A common chemical test on gunshot residues called the modified grease test. The modified grease test is performed first on the exhibit. When I say exhibit, I mean item. Okay, so just any item that we're trying to test for, because it will not interfere with later tests for lead residues. So the modified grease test is a test to detect the presence of nitrite residues, which are the byproduct of combustion of smokeless gunpowder in guns. This is the primary test used by firearm examiners to determine a muzzle to garment ratio. So like if the gun is pretty close to it, it should have that residue left behind. So this is them performing the modified grease test. Basically, you don't need to memorize all these chemicals, but there are chemical mixtures that are used. They are put onto this piece of paper. Okay, so this photosensitive piece of paper is soaked in this chemical. Whatever item you are testing is processed by placing it down onto this paper that has been treated with the chemicals. It is heated, a lot of times with just like an iron, heated onto it. And if the powder that is on the item reacts with the chemicals on the paper to turn an orangey color, it was gunshot residue. And this is just kind of an example of what it would look like the orange paper, like what it would look like, determining how far away the person was standing when they were shot. So if they're really close, you're going to get a bright orange, lots of little orange dots. And the further away you get, the less you're going to see on the paper. And that's where we're going to stop. New trajectory is our last thing that we'll cover tomorrow, pretty sure.